let us do this thing. Let's do this. Okay, well, this is an awfully boring slide. Where's all the color? There was all the reds and stuff before. All right, so I want to talk a little bit about process mapping, developing algorithms. A lot of people know this, but don't know it necessarily as an analytical model, which is why I'm going to bring it up. Because we actually use process mapping and algorithms in a variety of ways, and we use a variety of decision-making heuristics. And each of these they're kind of embedded into a genre family of sorts. We'll talk about that in a minute. But if we're just trying to understand why I would talk to you about algorithms, if you did not watch PTS for writing, go back and watch that. It will explain a lot. In writing, we spent, in the discipline of writing spent over 3 decades and continues to, in some cases, uh, discussing the idea of process or the writing process. And this became a complex thing. There's a whole lot of ins and outs to it that, and some infighting that didn't need to happen. But essentially, they realized that writing is a process, that it's not just a write sitting in, you sit down in 6 hours, one shot, write, and you've got a product. But a lot of times all we see is the final product. But the process for developing that product, we want that an effective process that leads to a more effective product of writing, so that that final composition, that final essay, that book, that blog post, that text to your mom, the grocery list, that it works, that it does its job, that it's rhetorically effective. So the importance of process mapping and being aware of writing process or any sort of process is, by taking the time to map it, you can better evaluate it, analyze it, its effectiveness. How well is it doing what it's supposed to be doing, and can we improve upon it? I have a friend in chemistry whose wife is a process engineer. That's kind of cool. Just saying. Moving on. So process mapping, algorithms. Developing an algorithm, according to dictionary.com. See, I'm really pulling out the big guns here with dictionary.com. I didn't even bother to look up an academic source in like computer science. Here's what we got though. Developing a process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer. Computers used to be people. Ever watch that movie about called Hidden Figures? Uh, you'll know what I'm talking about. NASA used computers, and they were people before there were computers that we would think of. Anyways, writing technologies, it's cool. An algorithm is basically a decision-making process that people or computers use consistently to accomplish a goal. When people repeat the same general process, we call that a routine, like when we get ready in the morning, like when we plan for our week, like when we sign up or register for classes, which is not something you should be doing in my class while I'm talking to you. If you're watching this video, that's not an issue, is it? Thank you. And that's beside the point. So bottom line is, when we're developing algorithms, we're talking about the ways, the rules we use to figure something out. Sometimes it's mathematical calculations. Sometimes in computer science, it'll be used for like if-then statements and that sort of thing. So if this language sounds familiar, it will likely sound familiar to you if you've done much with computers or computer coding. In writing, we've talked about, there's a nice piece by Mike Rose that talks about heuristics and algorithms. But essentially, the idea is that a heuristic is a soft plan. It's meant to be more conceptual, and it's meant to give a more conceptual and more flexible. And so heuristics are kind of mentalities or approaches we can use to engaging with a problem. But if one heuristic doesn't work, we can shift and stay flexible. An algorithm is a bit more locked in, but in computer science and in coding, it ends up being kind of the pattern of the program, or the outline of the program, and then the specific code of a specific programming language might change a little bit, but the algorithm can be used in a couple different program settings. And so this may not be something you care about, but it can be helpful when we're trying to figure out, okay, how do we go from point A to point B to point C to point D to point D point 1, point D point 2, and so on. I don't know why I did it that way, but fine. I'm joking. I have reasons. So suffice to say, Process mapping is important, and we do it on a daily basis. If you watch that fun video, it'll talk about things like sorting laundry as an everyday thing. But suffice to say, people use invisible algorithms in their head all the time, decision-making processes that we don't even realize we have sometimes. Whether that's in a dating relationship, whether that's when deciding whether we want to hang out with somebody, whether it's deciding whether to go to work or school that day, or to call our moms on the weekends, or whatever it is, or to take over a nice plate of cookies to our neighbor. There are decision-making algorithms we walk through and processes and logics behind what we do, and we want to be able to put that out into something that we can better understand, so that we can think through our thought process. Thinking about thinking. This is very metacognition. It's a thing. Go look it up. Okay, so with that, as we think about how to map processes, we can think of algorithms as its own genre, and it has a genre family of sorts. So there are things we can do to map algorithms or to map processes. We can look at things like flowcharts. We might look at schemas, or schematics, kind of same root word. Or if we're doing lab reports, or if we're doing science writing, the methods section in an IMRD formatted essay is essentially an algorithm for writing or for accomplishing that experiment. There are some rhetorical components that we need to think about, but I'm not going to argue that point right now. So don't get mad at me, Mike. You know who you are. Sometimes an outline can be sorry. So the method section of an IMRD formatted essay is essentially a process map. It's meant to be a step-by-step sequential way of accomplishing the experiment if someone were going to replicate it. Flowcharts we can also use as a form of process algorithm to say essentially like, if yes, do this, if no, do this, and we keep working down those trees of decision making. So if you can follow the link if you don't know what a flowchart is. Sometimes when I start talking about this, people go, oh, process mapping, algorithms, that's kind of like an outline for an essay. And I'd say, yeah, sort of. Back up. So it's an outline is specific content in simplified form. So in some ways, it's like an algorithm, but it's important to understand there's a difference between a process for something and content for something. And so a process is something we replicate over and over again. We do the same process or versions of the same process consistently across multiple projects or decisions or whatever it is. An outline, however, is a specific essay's content in simplified form that gets at the structure of it. So in some ways, yes, but when an outline only maps the structure of a single text, whereas a process algorithm talks through what is effective about each step and it links to the steps you take that can be replicated across a series of problems or a series of texts. So it's different. So it's one thing. So process mapping is closer to genre, and an outline is closer to the specific text, if that helps make a distinction for some people. The idea, though, is that process is mapping a replicable structure, and outline is mapping the structure of a single text or moment in time. So that's a disambiguation that might be important for some people or might be meaningless to others, depending on how much you really care. I hope you do. I hope you care. And you're not just stuck watching me talk to you this way. I apologize. I'm doing that thing where I waste your time again. Moving on. So as we look at this, let me give you some fun examples we can think about. So just as a few examples, here are some examples of process algorithms. I've got a fun one connected to should I throw my manuscript under a lawnmower? I did get this from the internet. I realize in hindsight that there is not a source on that, and that's not a good thing for me to do. I should probably go find that and put that in the comments below. Apologies, whoever created this. It's amazing. Thank you for making it available on the internet. That is a terrible thing for me to do. I'm going to fix that. All right. Similarly, there is a flowchart for figuring out what reaction type. So I use that. I borrowed that from something we talk about when we discuss process mapping and algorithms in a chemistry learning community I have with writing. And so but essentially, each of these are texts for mapping a process. And if nothing else, the one on reactions points to the fact that scientists and people who study science do writing that they don't always realize as writing. So if you think that becoming a scientist will get you out of the writing game, you are wrong. Instead, you get to create cool things like this, or more than likely, you're writing a lot of lab reports, and you're still going to have to be able to do these things that I'm trying to teach you how to do. If you don't believe me, go ask my chemistry friends. Who are they? I'm not going to drop names. They're too cool. I'm just kidding. Mike McFarlane's a great chemist to follow. He'll tell you how much writing he has to do that he didn't expect to do. Go ask him. There's also research on it, but I just like name dropping because Mike's cool. He also has his own YouTube channel with every lecture he's ever done at Chandler Gilbert Community College, and you should watch those because they're fun. All right. With that, I don't think I have anything else on process algorithms, and that's actually a good thing because this is now the shortest video, I think, in this series so far on the analytical aspect of writing, and I'm not going to fill it up with any more wasted text or words like this. I'm doing it right now. With that, suffice to say, the importance of understanding process algorithms is that we understand how to map out our thinking and our decision-making processes so that others can replicate it, so that we can analyze it, or so that a machine can duplicate it through code. And that is pretty cool. Um, it applies to things in the sciences. It applies to every decision-making process we make on a daily basis. And by analyzing our thinking using mapping like this, or providing deliverables in the form of process maps, flowchart schemas, we can enhance our impact on the people around us and better communicate through those specific genres and models. Cool. Have fun, and on to SWOT analysis if you're just watching these, binge watching these.